Hi everyone and welcome to this lesson. Today we are going to learn about synthetic division, another method for dividing polynomial expressions. Before we get started, I'd like to emphasize one very important point. Synthetic division is a much simpler and faster alternative to long division. In fact, the word synthetic suggests that we are using a more streamlined method. However, this method does have one important limitation. Synthetic division can only be used when the divisor is a linear binomial of the form x minus b. Now, we are going to go through the entire process of dividing by x minus b, and we'll try to tweak this method to allow us to divide by binomials of the form ax minus b as well. For now, I'm going to get started with our first example. We're dividing 3x cubed minus 5x squared minus 7x minus 1 by the binomial x minus 3. So first we want to make sure that all the terms are listed in the descending order of power, so from highest to lowest degree. And if we have missing terms, for example, this is a third degree polynomial, so we have an x squared, we have an x power 1 as well, we have x power 0, so we have all the terms in this case, but if we had a missing term, then we will have to fill the polynomial in with 0x to whatever power is missing. Now, next, we will have to list the coefficients of the dividend, so of the polynomial we are dividing. And the coefficients are 3, negative 5, negative 7, negative 1. Next, we will determine the zero of the divisor, or the value of b. So the divisor is x minus 3. We're going to make it equal to 0 to find the zero of the divisor, because that allows us to identify the value of b with accuracy and without having to think that hard. Obviously, this is not a step that you have to show, because you can tell that when dividing by x minus b and your binomial is x minus 3, right away you can tell that the value of b is 3. Now that number 3 will go right here. Now we're going to start dividing by bringing down number 3, the first coefficient in the polynomial. So next, we'll multiply number 3 with the value of b, which is 3. So 3 times 3 would equal 9. We're going to write 9 right underneath negative 5. And next, we'll add these two numbers. Negative 5 plus 9 equals positive 4. Now the process keeps repeating. We are multiplying this time number 4 by number 3 again. So 4 times 3 equals 12. We're going to add again. Negative 7 plus 12 equals 5. Again, the same process. We're going to multiply 3 by 5 and we get 15. We'll write number 15 right underneath the next term and we'll add them. Negative 1 plus 15 equals 14. As you can see, we have exhausted all the terms, and this is where we stop. Now we're thinking, what is the answer in this division? Now I want you to think, if you're dividing a third degree polynomial by a first degree polynomial, what would be the degree of the answer? Normally, if you have x to the power 3 divided by x power 1, then the answer will be to the power of 2. It works in the same way when the polynomials are bigger than that. So the very first term in here will be the x squared term. The next one will be the x term, and the last term will be a constant. As you can see, these coefficients are positive, which will make the answer, or the quotient, 3x squared plus 4x plus 5. So we'll say that the quotient qx equals 3x squared plus 4x plus 5. Now you're wondering, how about this number here at the very end of the division? What do you think that is? That is going to be the remainder. And this is how we perform synthetic division by a binomial of the form x minus b. Now you have another example that you can try on your own. This time, as you can see, you have a fourth degree polynomial. So we are going to have to rewrite this from highest to lowest degree x4 minus 2x cubed. We don't have an x squared term, so we're going to have to write 0x squared. The x term is 13x, and then the constant negative 6. We're dividing this by x plus 2. So we'll begin by listing the coefficients. So the coefficients are 1 for x to the 4, negative 2, 0, 13, and negative 6. Remember, it is very, very important to fill the polynomial n with terms that have a coefficient 0. In long division, we could see the powers, but now we don't see the powers. But we just know that all these coefficients will represent 1 degree lower. Now, we have to determine the value of b. So remember that x minus b is the divisor, the standard form of the divisor. And when we see that we have x plus 2, it means that we must have subtracted a negative 2, which makes the value of b equal to negative 2 in our case. Again, an easy, quick way to get the value of b is by simply making the divisor equal to 0 and then solve for it. So you see that we get negative 2 here. Now, we're going to build that little triangle, half a rectangle, and we are going to list the value of b right on the side here, negative 2. So the process is pretty much the same. So we're going to bring 1 down. And then we'll multiply 1 by negative 2. 1 plus negative 2 is negative 2. Add them. Negative 2 plus negative 2 is negative 4. So again, multiply negative 4 by negative 2. It's the same repetitive process. That would be 8. 0 plus 8 equals 8. Here we go again. 8 times negative 2. That would be negative 16. Add them. 13 plus negative 16, negative 3. One more. Negative 3 times negative 2. That would be positive 6. We add, and we'll get 0 at the end. Now we're thinking, what is the answer? What's the quotient? Well, we have to think, what are we dividing? We're dividing power 4 by power 1, which means that the answer must be power 3. So the first number here will represent the coefficient of the power 3 term. So we'll have 1x to the power of 3. The second one will be the x squared term, and then we have the x term, and lastly we have the constant. So if you don't see any signs, then you have to put a plus in there. So 1x to the power 3, you just write x to the power 3 minus 4x squared plus 8x minus 3. This will be the quotient. Let's make it green like we always have, actually. Not that it matters. But if you're OCD, it does. And as you can see in here, you have the number 0. And the number 0 will represent the remainder. And this is how synthetic division by x minus b works. So try some more questions on your own. And in the next video, we are going to look at division by ax minus b. You have some more practice questions down here, so you can stop the video to record them and practice on your own. Until then, bye for now, and most importantly, thank you for learning with me.